Hello again. In this video, we're going to go over section 2.5, part 3, which is about the end-behavior of rational functions. Now, in the last video, we talked about the end-behavior of polynomial functions. So in this video, we're going to focus in on the end-behavior of rational functions. And so let's find the end-behavior for these three rational functions in example 3. Okay, now if you remember, the idea of end-behavior is what you're trying to do is you're trying to find what the y value is approaching as x heads towards infinity and negative infinity. So let's find the limit of this function as x heads towards positive infinity first, and then we'll look at what happens when x heads towards negative infinity afterwards. Now initially, if you try to evaluate this limit, you can see that as x heads towards infinity, this top piece is heading towards infinity, but so is the bottom piece. And so you end up with this form of infinity over infinity, and that's actually an indeterminate form. And we talked about indeterminate forms before. In a previous video, we had the indeterminate form of 0 over 0, and what we attempted to do there is change the form to a different form so that we could actually determine what the limit is. So we're going to change it into a determinable form, and that's exactly what we're going to do here. So the form that this is in now is indeterminable. We're going to change it to a determinable form. Now, the key with these rational functions, the way you turn them into determinable forms, well, at least for this one, the way you would turn this one into a determinable form is what we're going to do is we're going to multiply top and bottom of this rational function by 1 over x squared. Now notice 1 over x squared divided by 1 over x squared is equal to 1. So I'm not changing the value of this function, but I am changing the form. And why am I choosing x squared? I'm choosing x squared because that's the term down here on the bottom of this rational function. We never use the top. You always look at the bottom. This happens to be a second degree polynomial on the bottom, and that's the reason I'm using 1 over x squared. Okay, so let's see what this reduces to. Now you have to distribute this 1 over x squared to both of these. So you get 3x over x squared plus 2 over x squared, right, when you distribute this to both of those terms. And then on the bottom, you get x squared over x squared plus or minus 1 over x squared. So just distribute the 1 over x squared, okay, to each of those terms. Okay, and then we're going to take the limit of this as x goes to infinity. Now you can see that this reduces. This becomes 3 over x. That's just 2 over x squared. This is 1. And then minus 1 over x squared. Okay, and then we're going to take the limit as x goes to infinity. Okay, so the reason we did this is notice that after multiplying by this 1 over x squared, every one of the terms that I have here, I have forced the x's into the denominator. And that's important because if x is in the denominator and x is heading towards infinity, then something like 3 over x would head towards 0. So this is just going to get closer and closer to 0, as well as this, as x heads towards infinity. And so is this. And so I think you can see that the top is getting closer to 0, whereas the bottom is getting closer to 1 minus 0, which is 1. And so this is heading towards 0. So the limit of this function would be 0. All right, so that's the end behavior on the right-hand side. As x heads towards infinity, the y value of this function is getting closer and closer to 0. Okay, we also need to check the end behavior as x heads towards negative infinity. But it's the same. So I'm going to write this as plus or minus infinity. And I'll show you that it's the same. Okay, let's say this is heading towards negative infinity. X is, right? You would still go through and simplify it or change the form of it by multiplying by this. And you would end up with this form here, which is the determinable form. But now you look at this and you go, okay, x is heading towards negative infinity. This 3 over x is still going to head towards 0. This is still going to head towards 0, and this is still going to head towards 0. The fact that it's heading towards negative infinity has not changed that fact. All of these head towards 0, regardless of whether x is heading towards positive infinity or negative infinity. So this limit will still end up being 0, even in the case when x is heading towards negative infinity. So one way of writing this is just to do it all at once and say plus or minus infinity. So as x heads towards plus or minus infinity, this limit is 0 in either case. Okay, so that's the end behavior on both sides. Towards the right and the left, the y value is heading towards 0 for this function. Now let me show you a graph of it real quick. So if we were to graph this function that we're working with, I think you can see as x heads towards infinity, they don't show a lot of the rest of this graph, but as x heads towards infinity, what happens is this graph continues to creep down towards the x-axis. So the y value is getting closer to 0. And then as x heads towards negative infinity, you can see as x is heading towards negative infinity, the y value is creeping up towards 0, right? A y value of 0. Okay, so yes, in both cases, the end behavior is 0. Now, remember, this means that there's actually a horizontal asymptote at y equals 0. Okay, we talked about that in the first video from this section. When you have a limit at infinity heading towards a finite number, that indicates that you have a horizontal asymptote right at that number. Okay, so we're heading towards 0. Right? We have two limits at infinity that are heading towards 0. And so that means we have a y asymptote, a horizontal asymptote at y equals 0. Okay, so if you want to draw that in, there's a horizontal asymptote right at y equals 0 here. Okay, so let's look at the next one. Okay, so this is the next rational function that we're looking at. So again, in this case, initially when you look at this limit, and I'm going to look at plus or minus infinity at the same time. X is heading towards plus or minus infinity. When you initially look at this limit, you're heading towards either infinity on top and infinity on the bottom. So you have this indeterminate form. And by the way, you also have an indeterminate form if this is plus or minus. Doesn't matter which one. Okay, plus or minus infinity or infinity. Okay, so that's the form this is in right now. Okay, so we're going to do the same thing. We're going to look at the bottom polynomial, which is degree 4. And so what we're going to do is we're going to multiply this rational function by 1 over x to the 4th. Okay, so now we distribute the x to the 4th to each of these terms. And you can see that you're left with 40 x to the 4th over x to the 4th plus 4x squared over x to the 4th minus 1 over x to the 4th. And then on the bottom, distribute this to each term. You get 10x to the 4th over x to the 4th, 8x squared over x to the 4th, and then 1 over x to the 4th. Okay, and then we're going to find the limit as x goes to plus or minus infinity. All right, so let's just simplify this first. These would cancel out. You're left with 40. This would leave you with 4 over x squared. This is 1 over x to the 4th with a minus sign in front. These cancel out. You're left with a 10. Here you're left with 8 over x squared, and then here you're just left with 1 over x to the fourth. Okay, and then we're going to find the limit as x goes to plus or minus infinity. Now, this is the determinable form. Regardless of whether x is heading towards positive infinity or negative infinity, each of these terms is getting closer to 0. And so you can see the top is going to get closer to 40, whereas the bottom is going to get closer to 10. So this is going to get closer to 40 divided by 10, which is equal to 4. Okay, and so a quick look at the graph of this. So the graph of this function looks like this. And you can see as x heads towards infinity, this y value creeps up towards 4. And it does the same thing as x heads towards negative infinity. All right, so it's creeping up towards 4 as you head towards positive infinity, but it's also creeping up towards 4 as you head towards negative infinity. And that means you have a horizontal asymptote at y equals 4, which they've drawn in here. Okay? All right, so now let's look at part C. Okay, so now let's find, again, we're finding the end behavior of this polynomial, or sorry, this rational function. So we want to find this limit. And so again, what you do is you look at the bottom polynomial, right? The bottom polynomial is a first degree polynomial, so I'm going to multiply this by 1 over x. 1 over x to the first. Okay, and now let's distribute that. So you get x cubed over x minus 2x over x plus 1 over x. And then on the bottom you get 2x over x and 4 over x. And then let's just reduce this. This becomes x squared. This becomes minus 2 over x. I'm sorry, just minus 2 because the x's cancel. Okay, plus 1 over x. And then on the bottom, you just get 2 here, plus 4 over x. Okay, now let's just let x run to plus or minus infinity. And see, notice again, as this happens, this heads towards 0 and this heads towards 0. And so on the top, as x is heading towards infinity, x squared is also heading towards infinity, right? This is just going to get larger and larger and larger as x gets larger. So this is sort of like a really big number minus 2, which is still a really big number, plus something that's really close to 0. Okay, well, the minus 2, subtracting the 2 and adding the really small number close to 0, those are insignificant compared to what's happening here. This is a really large number. Subtracting 2 from it and then adding a little bit more doesn't really affect the fact that it's a really large number. So what's going to happen? This is going to head towards infinity, the top part, this entire top part. Now this is heading towards 0, but this entire top part as a whole is heading towards infinity. And that's also true if this were negative infinity. Negative infinity, because you're squaring it, that would still be a positive number, so this would still head towards positive infinity. Now, on the bottom, this is heading towards 0, but this entire thing right here is heading towards 2. So it's a really, really, really big number divided by something that's really close to 2. Okay? That's still a really big number. I don't care if you divide it by 2 or by 3 or by 4 or numbers close to 2 or 3 or 4, whatever it is. Dividing by a number that's really close to 2 when you have a really large number on top doesn't really change the fact that the number on top is just going to continue to get larger and larger. Okay, so this indicates that it's heading towards infinity. Okay, so the end behavior in this case is it's heading towards infinity on the right and the left. So let's look at the graph and see if it matches that. Okay, so here's the graph of the function, and I think you can see, look, as x is heading towards infinity, the y value is heading towards positive infinity as well, and as x is heading towards negative infinity, the y value is heading towards positive infinity as well. So the end behavior for this function is up on both sides. Okay, so next time, I'm going to look at the end behavior of a special case of a rational function where you end up with slant asymptotes. So hopefully you'll get a chance to look at that one as well. Thank you for watching. Bye-bye.